Hey everyone, this is Reshma from Edureka, and in today's tutorial we'll be learning about OpenStack. So let us get started by looking at the agenda, but before that, am I audible to everyone? Drop me a confirmation on the chat window, please. Okay, so Anna says yes. Zahir says they can hear me. Okay, thank you, Paul. Yasmin. Alright, let's begin, guys. So this is what we'll be covering today in today's tutorial. So first we'll take a look at what is virtualization, just the basic concepts of virtualization. Then we'll jump on to what is OpenStack and why should we actually use OpenStack. I'll tell you about the OpenStack components and the OpenStack architecture. We'll take a look at the different OpenStack services and we'll take a look at a case study. And finally, we'll see the OpenStack success stories. So is the agenda clear to everyone? Okay, so I've got a few confirmations. So let's begin. So let us start with what is virtualization. So on the left-hand side, you'll see this is the basic architecture that is without virtualization. So you have like your proper hardware, your CPU, your memory storage disks, your NIC for networking purpose, disk for storage, and on top of that you lay out the x86 architecture, which is basically your computer architecture, like your 64-bit or 32-bit architecture that you have in your computer, about how each of the process takes place, the process queues and everything, that kind of architecture. And on top of that, there is the operating system or the user interface with which the user can actually interact with the hardware for different purposes. And inside that, there is your application. So this is what you run inside your operating system. Now, virtualization basically means actually logically partitioning everything. Or let's say it is going to duplicate your hardware and divide it into different components. If you see, you can use different softwares for virtualization. It can be VMware or it can be KVM, Xen, or any kind of hypervisors that you can use for virtualization. We widely use the Oracle VirtualBox Manager also to actually use VMs. We widely use Oracle VirtualBox Managers for virtualization, for actually working on VMs, creating VMs, and working on them, right? So this is the virtualization architecture. So you have your basic hardware that is always needed, obviously. And on top of that, there is your machine architecture. And inside that, you use software for virtualization. And what this software exactly does is that it replicates your hardware, but in an abstract manner. So this is not a real hardware. So when you virtualize it, does not actually divide your hardware components. It actually creates an abstract form or a virtualized form of your hardware. And it can be either, you can actually logically partition it in either two parts or more, as many parts as you need it. And on each platform, you can run different operating systems, and on different operating systems, you can launch different applications. So this is what virtualization actually is. So this is just a logical partitioning in an abstract manner. So is that clear to everyone? Any questions about virtualization? So this is just a brief overview of what we're actually going to deal with, because OpenStack actually deals with a lot of virtualization. So any questions? Okay, so Kunal says no questions. Okay, but if you have any doubts later on, you might ask me at any time during this tutorial. Okay, so now let us see what is OpenStack. Like OpenStack itself says that OpenStack is a collection of open source technologies delivering a massively scalable cloud operating system. So it is basically a set of softwares that enables you to build your own cloud infrastructure. You can think of it as a software suite that comes with different services that allow you to perform different activities and actually launch up your own cloud infrastructure on which you can actually run your applications, starting from development to testing and deploying it. And the best part about it is that it is open source, and it is said that open source cloud platforms are actually going to be the future of cloud computing. So OpenStack has got a lot of scope in it. And there are a number of companies that have been contributing to OpenStack, and by contributing I mean they are contributing code. And you can see that each year OpenStack is releasing almost 2 versions, and you can see that OpenStack is almost releasing 2 versions every year. And these are some of the companies that have been contributing the code. starting from Rackspace, and actually Rackspace was the one who actually created OpenStack in 2010 with NASA. And there are other companies like Cisco, IBM, Red Hat, VMware, Dell, HP, and these are just a few of the companies that are in the OpenStack community that have been contributing to OpenStack. So this is what OpenStack basically is. So after that, why should we actually use OpenStack? Let us understand why OpenStack was created on the first place. What was the need of creating OpenStack? So we'll see that. So here we have the consumer, and the consumer basically here could be application developers, or they might be application owners. So they want to build an application and they want to have an infrastructure. And most people actually support, or they want to go for a cloud infrastructure. So what they do is that they send requirements. They just write down what they need to set up their infrastructure, and they send it to an infrastructure team. Maybe they could be the infrastructure team of a cloud vendor. So they send all their requirements to them. They see the infrastructure team over here. They actually take a look at their requirements, whatever they need, and they create the infrastructure accordingly. After that, what happens is that the application developers or the consumers, they have got their own set of tools. Now, obviously, in order to develop an application, there are numerous amount of tools that you can use, and technology has evolved in such a way that these kind of tools have evolved and they enable you to develop your application faster. And among those tools, they might use Jenkins for continuous integration and continuous deployment. They might use Ansible or Chef for configuration management and automation purposes. Let's say Git for version control. So they can use different tools for that. And after they have got their infrastructure and they have tools, they need to configure their environments. And the environments could be development, testing, and production. So they have to integrate all these tools together. So this might be a little bit of problem if the configurations that the infrastructure team has actually embedded in the infrastructure they created for the consumer might not be compatible with the tools. The infrastructure might not have an integration with the tools that they want to use. So this is what the consumer needs to do additionally after even they have got their entire infrastructure defined. So it is better if they could actually create their own infrastructure themselves so that they can actually configure it themselves, and they would integrate with the tools they want to use, so it'll be more easier for them. And OpenStack enables you to do that. So you can create your own cloud infrastructure on premises. You can set it up as a private cloud. You can set it up as a public cloud. You can contact some OpenStack vendor that gives you OpenStack services. So you deploy your cloud infrastructure in a lot of ways with OpenStack. And mostly large enterprises would use OpenStack to set up their own private cloud because they might have sensitive data that they want to keep in their own data centers, or let's say in premises. So that's why people are actually going for OpenStack. So now let us compare OpenStack with a public cloud. And when you talk about public cloud, the one name that comes to your mind is always AWS, the Amazon Web Services. So Amazon Web Services gives you a lot of things. It has pros, and definitely it might have some cons also. So I've listed them out. So let us take a look at them one by one. So the first point that Amazon Web Services gives you is that it has very well documented APIs. So APIs are something that actually enables you to communicate between different services. And the APIs that AWS gives you are very well documented, and that's why you can just use them right away. And the processing is fast. There is full autonomy for developers. They can run any kind of applications on the servers that AWS provides. And AWS actually has a natural integration with the tools that I just mentioned, like Jenkins and Ansible, Chef, Puppet, Git. They have Amazon Web Services actually has got a natural integration with those tools, and those tools are fully compatible with it. And it also has a very well-defined ecosystem. And if we take a look at the cons, you would know that the APIs are proprietary, and there might be data sovereignty issues because when you're putting in data, it's fine. But if you want to take out your data from their server to your servers, you might face some data sovereignty issues. So this might be a problem that you can encounter. There can be environment differences. Let's say that if you are running development and testing on your public cloud or on your AWS servers, but you are actually deploying it, or the production servers is in your company premises. And also maybe while you're transferring data, you might be facing some security issues on making a VPN tunnel or something. So that's why some people do not prefer AWS. And if, let's say, and sensitive data, let's say that if your company actually has data that is sensitive and you don't want to rely on someone else's security, even though AWS has a very well security defined for your cloud, but still you might be a little bit dubious about relying on other people's security protocols, and you might not actually trust them. And so most companies prefer to keep their data on premises in their data centers, which is actually maintained by their own security protocols. So that is why some people do not go with AWS. And the benefits that you get with OpenStack could be it is vendor neutral. And by vendor neutral, I mean that it is a business and design approach to ensure that there is a broad compatibility of technologies, and it encompasses standardization and non-proprietary business principles and unbiased business practices. And of course, you can have your cloud infrastructure on premises, so you can define your on-premises or on-prem infrastructure. And obviously, you can have when you have everything on premises, so you can have dev, prod, and test all the environments integrated in a single infrastructure. So this is the benefit that you get with OpenStack. So Kunal has a question. He is asking, can you explain vendor neutral? Yeah, so vendor neutral basically means that there is compatibility. It means that it has no pre-configurations defined, so anyone can use it. And nothing is actually proprietary. Everything is non-proprietary, and all the business principles are unbiased. So it is free for everyone. So most of the open source technologies are vendor neutral, and so is OpenStack. So Kunal, did you get your answer? Okay, he says yes, very well. Thank you, Kunal, for the question. So moving on, let us take a look at the different OpenStack components. So these are the OpenStack components that make up OpenStack, and these are actually a bunch of services all together. So Horizon is the dashboard, so this is a web interface or a graphical user interface that enables user to actually see a brief overview of your entire infrastructure at once, and they can also provision themselves with Horizon. You can log in as different users. The Keystone is the identity service, or this is a service that actually maintains who is using what kind of a thing. The Nova is used for computing. The Glance is for image storage. Swift is for object storage. And in today's world, since you know that everything is actually stored as an object, and Swift is one of the services that OpenStack provides. And there is Neutron for network as a service. Cinder as a block storage component, Heat is used for orchestration, and Ceilometer is used for billing or metering kind of a service. So we're actually going to look deep into each of the services. So if you still have questions on this, you can ask me, but I'll just tell you that I'm going to explain each of these components one by one in a brief manner. So any questions? Okay, no questions, very well. So first up is Keystone. So Keystone is basically the authentication and authorization service. So by authentication, it means that it identifies if you can actually log into or if you can actually have access to the entire OpenStack infrastructure. So when you're using a dashboard, it will ask you for your username and password. So this is the part of the authentication system. And by authorization, it means that it will identify if you have rights to do or use a particular service. So that is what Keystone manages. And two functions that I just told, which is user management, it means that it keeps a track of users and what they're permitted to do. So this is the authorization and authentication thing mostly. And provides service catalog, it means that it provides a catalog of what services are available and where their API endpoints are located. And let me tell you that all of the services actually communicate with each other with API, and each of the services have endpoints defined. And by endpoint, endpoints are nothing but they are a network accessible address, and it is usually described by an URL from where you can actually access an OpenStack service. Okay, so let us take a look at Keystone. So the Keystone provides you with a token service. So the token service, what the token service does is that it validates and manages tokens that is used for authenticating requests once a user's credential have already been verified. So if you're able to log in into the dashboard or log into your OpenStack infrastructure, so if you want to use any kind of service, it sends different tokens to each of the service through APIs. And the catalog service, what it does is that it provides an endpoint registry, and it is used for endpoint discovery because you communicate with endpoints, right? And the policy service, it provides you with, let's say, a rule-based authorization engine and the associated rule-based user interface, or the rule management interface, you can say. And identity is the same thing that keeps a track of all the users. It identifies different users through their credentials. So any doubt on Keystone? And let me tell you that every time you actually want to access a service, it has to get validated by Keystone. So if you request for, let's say, compute service, you request for storage, Keystone needs to verify it, and after that only you get that service. So Keystone is actually associated with every service. So no doubts? Great. So the next up is Glance. So Glance is the service where you store all your images, okay? And the images are nothing but they are the virtual disk images. So you can think of Glance as a repository for your virtual disk images. And it provides a service where users can upload and discover data assets which are meant to be used with other services. So let's say that if you want to actually launch an instance, if you want, let's say, an Ubuntu instance, you must launch it from an image. So the image from where you launched that instance, that has to be in Glance. So this is where you store your images, okay? And it uses a RESTful API. And RESTful API, you know what they are. They send HTTP requests and they connect with each other by passing on HTTP requests. So Glance uses an RESTful API. And this is the API server, and this allows querying of different VM image metadata as well as retrieval of your actual image. So your images can be stored in S3, in Swift storage, or in file systems, or anywhere. So this is the image service. So whenever you ask for an instance, you should know that the Glance is the service that is actually going to provide you with the instance, because your instance has to get launched first from an image. So you can see that this includes images and metadata definitions of your images. So the disk format that Glance uses is mostly QCOW2, and this is the disk format that is supported by the emulator, and it can expand dynamically, and it supports copy and write. So any questions on Glance? No questions? So we'll move on to the next service, which is Nova. Now Nova is the compute zone. So this is where your instance get launched in, and this is where all the computing and processing takes place. And in Nova, all the components that are in Nova, they all communicate through message queues, and mostly they use RabbitMQ for message queuing system. So each of these components, starting from scheduler, conductor, the database, and the different hypervisors, network, this is the VM over here. So all the components communicate using the RabbitMQ message queuing system. So you can see that OpenStack Nova is a component with the OpenStack open source cloud computing platform developed to provide on-demand access to compute resources for provisioning and managing large networks of virtual machines. So this is where you can actually configure the network for your VM. So you can store data inside your VM, and later on they will be either stored in Swift or Cinder. So I'll be explaining how each of the components work in Nova later in the architecture part. So if you have any doubts still here, you can ask me. Do you have any doubts? Okay, so Anna is asking that, is Nova similar to EC2 Compute in AWS? Of course, EC2 is also the compute service or the computing service in AWS, and OpenStack, you can think of it as Nova. So they are actually quite similar. So if you have any more questions, you can ask me. So moving on to the next service. So then we have got Neutron. Neutron is a service in OpenStack that provides you with NAS, which is known as Network as Service, and Neutron is responsible for actually connecting all the different services of OpenStack together. So this is how the Neutron service is laid out. So it also uses an APIs, and it has got a Neutron scheduler, different plugin agents, and there are different plugin agents for Cisco virtual and physical switches, NEC OpenFlow products, Open vSwitch, Linux bridging, and the most common agents are L3, DHCP, and some specific plugin agents. So in the Neutron, what the Neutron server does is that it accepts API requests and it routes them to appropriate plugins for action. So I'll be explaining how Neutron also works in the architecture part. So Yasmin is asking that what do you mean by ships with plugins? It means that when you are installing Neutron service of OpenStack in your system, you would already get different plugins that are compatible with different kind of agents. And the examples that I gave you are the different plugins. So sometimes because if you're actually downloading just the Neutron service, you might want to use different plugins to connect to other services. And when I mean that it ships with different plugins, it means that the version already has got all those plugins, and the plugins will also get installed when you're installing Neutron. So Yasmin, did you get your answer? Okay, so she says yes, very well. So next up we have got Swift. And Swift is the object storage service for OpenStack. So in today's world, you are actually storing huge amounts of data, and the data storage system has changed. Nowadays, everything is stored as an object, and Swift is the service that allows you to do that in OpenStack. So in Swift proxy, so whenever any request comes for storage, the Swift proxy gets that, and after that it redirects it to the proper containers or to the proper database where it should get actually stored. So you can see that the Swift proxy handles every request. It can store data according to some account. It will go to let's say a defined user database, or you can store all your data in different containers. And you should know that if you want to define containers, now containers are nothing but different folders. You can think of containers as folders in your system that you are using, and you can store different objects inside the containers. The only difference between a folder and a container is that containers cannot be nested. It means that there cannot be containers inside a container, whereas in folders you can have different folders in a folder, right? So this is the difference between a folder and a container. And you can also directly store it in an object store without defining a container. So this is how Swift works. So any question on Swift? Okay, no questions. So let's move on to the other storage service, which is Cinder. Now, Swift was an object storage service, and this is a block storage service. The difference is that this can be thought of as an external hard drive or a pluggable storage device. So you can think of it as your external hard drive that you plug into your computer for storing your different files or folders. And in Cinder, everything is defined in blocks. So each of the block has got a predefined size, and the data is stored in each block. So these are the different components in Cinder. You've got the Cinder API and Cinder volume, Cinder database, and Cinder scheduler. We'll learn how each of these components work in the architecture part. So this is just to have an introduction to Cinder. Okay, so Zahir is asking, can Cinder also store images like Swift? You can store any kind of data you want to store in Cinder. You can store images. The only thing is that, yeah, Glance stores all the images in the Glance database, but you can also store it externally in a pluggable storage device like Cinder also, and it will go through Glance. It will get, and after that it will get launched in Nova. So that is how it takes place. The storage, you can even store images or any kind of data in Cinder. So does that answer you, Zahir? Okay, so he's asking why not only Cinder? Because the services are defined. Cinder is solely responsible for storage only. It does not directly communicate with Nova. So it has to go through Glance. If you want to launch instances with the images in Cinder, it has to go through Glance. So this is how it is actually, all the services are defined. So if you're using Cinder for both images, to launch images or store images, that is going to be used by Nova. And also as a pluggable storage device, that is too much workload for Cinder, isn't it? So it'll be more advisable if you use Cinder. And Cinder is actually only created for a pluggable booting device. So does that answer you? So I hope it answered your question. So shall we move on to the next service? Okay, so Zahiri says yes, and so let's move on to the next service, which is Horizon. Okay, so Horizon is the dashboard. So this is usually a web-based interface through which you can actually take a look at your entire cloud infrastructure. You can manage your infrastructure with this dashboard, all the different application developers or tenants. So the application developers are generally referred as tenants. So they can get provisioned with VMs that they need from the Horizon itself. So you don't have to actually go to the CLI to start and write commands to launch an instance and provision them to a particular user. So you can use Horizon for that. That is much easier. And Horizon is based on a Django module, and it is called the Django OpenStack. So the end user and the admins, they directly communicate with all the services to the dashboard Horizon, and they can access all the services from the dashboard. So this is very important, and I'm also going to show you how to use Horizon in today's tutorial. And it's very easy to manage your OpenStack cloud infrastructure with Horizon. It is very, very easy. Okay, so Kunal is asking, we can use CLI also, right? Yes, of course, you can use CLI instead of Horizon. If you don't want to use a web interface, a GUI, and if you're a person who likes to use the command line interface for and write commands and do stuff, so you can use CLI also instead of Horizon. So this is optional, but I would recommend you to use Horizon because it will help you to manage your infrastructure in a more easier way. So next up we have got Ceilometer. So Ceilometer is a part of the telemetry project by OpenStack. So what it does is it offers metering and it helps you for billing purposes. So what it does is that it lets you know what kind of services you used, what actions each user performed, and how they have actually used all the OpenStack services. So the Ceilometer is a service that is responsible for monitoring all of the actions that you did or any of the users of your OpenStack cloud infrastructure did. And later on, Ceilometer is used for producing the bill of how many services or for how much time you have consumed each service. Yeah, so Kunal is asking, why is this billing? Because sometimes let's say that you have set up your own OpenStack cloud infrastructure and you're letting other people use it. So this is also how different people are using OpenStack. The cloud vendors are setting up an OpenStack infrastructure and they're giving out OpenStack services. They're letting other people use OpenStack services. So with OpenStack, you can also define public cloud. So there are many enterprises that they do not want to take the hassle or they don't want to take the burden of actually installing OpenStack and setting up their own cloud infrastructure. When they just want to use a few services, they can buy it from an OpenStack vendor. So for those vendors should use Ceilometer so that they can produce a bill for the consumer that have consumed the services. So did you get your answer? Okay, very well. So let us move on to the last service that we're going to see, which is Heat. Now, the Heat provides you with a REST API to orchestrate different services. Now, orchestration is very much required when you are using automation, and today everyone uses automation. So Heat is responsible for orchestrating different services, and orchestrating means defining how each service would get consumed and how each of the service will get triggered. Let's say that it will maintain that it has to go to Keystone whenever you request something. The Keystone should get triggered. It will get a token to Keystone. So the Keystone will get triggered. It will authenticate the token, send back the token to the service that generated that token and verify. So, and then maybe it will trigger some other service according to the request of service that you have made. So this is the whole purpose of heat. So maybe you have got different nodes together. Okay, so you have got in region 1 you have got a compute node, a networking node, a storage, and you have got region 2, and you want these two regions to actually communicate with each other. So the heat service will help you orchestrate, help you integrate all of these two regions together. So this is how heat works. So any questions? So no questions, very well. So now let us move on to the OpenStack architecture. So here I will tell you how your request gets processed, how each of the service get triggered, and what each service actually do, and also what each of the components of each of the services do. So we'll take a look at it. So mostly, let's say that you're a user and you're accessing OpenStack through the dashboard Horizon. So the first thing that you need to do is log into Horizon. And let's say that you want to access a VM. You want to launch a VM and you want to work on a VM in your OpenStack infrastructure. So the first thing that you have to do is log into Horizon. And what a Horizon does is that it provides a baseline user interface for managing all OpenStack services. And it is also stateless. It doesn't require a database. And the Horizon gets updated via API polling. Okay. So after you have entered your credentials, what it does is that it sends a request to the Keystone API. And the Keystone actually, you know that it manages different user credentials, tokens that is associated with each user. And tokens are nothing but they are an arbitrary bit of text that is used to access resources. So what happens after that is the user gets a token from Keystone, and the token includes the list of user projects and roles in them. And after that, the user calls the service specifying the token, and the service interprets the roles, okay? And then Keystone validates the authentication data. So, and these are all actually done by APIs, and these APIs are REST APIs that sends HTTP requests to each other. So Horizon sends an HTTP request to Keystone, and Keystone sends back an HTTP request to Horizon after it has verified the credentials of the user. And since you requested for a VM, the VM can be launched in the Nova compute zone. So what Horizon does is that it sends an API request to the Nova API. And it actually sends in the form of post request to Nova API, and it is signed with the given token by Keystone. And Nova API also uses RESTful API service, which is used to interact with Nova. And this is the only allowed way to interact with Nova, and it is also stateless. It means that it requires no database. So after that, the next step is to validate the API tokens. So it sends back a request and it processes the API request. So what the Nova API does is that it parses requests to a Python object model, and it validates by fetching the data from the Nova database. And if the request is valid, it will save the initial database entry about the requested VM into the database. And these are all the Nova subcomponents. There is the scheduler, there is the conductor, and this is the message queuing system, and this is a unified way for collaboration between all the subcomponents or the components of Nova. So how the messaging process actually happens, let me tell you that first thing that happens is that it creates an update in the Nova database. So let's say the first component, the scheduler, will send JSON messages with a receiver ID. So this might be the receiver and an entry ID to the RabbitMQ. So this is the message queuing system that Nova uses. And then the other component, which is a receiver, this will fetch the message, unpack the entry ID, and process it in the database. And the Nova database gets entry by the entry ID, and it takes it up for further processing. And it actually uses two modes. And it uses RPC calls, which is known as the request procedure call, where you can actually make requests to one program which is actually in a different computer or in a complete different network. And the baseline or the rule they follow is that they do not know that they are in a different computer. Irrespective of the network indifferences or the environment or the computer indifferences, they can communicate with each other through RPC calls. So they use either RPC cast, or RPC casting means it does not wait for results. It means just fire and forget. And RPC call is where you actually wait for a result when you're actually expecting something to get returned. Okay, so this is what happens. And after that, you have to publish the provisioning request. So it will then again send an authentication request to the Keystone API. So the Keystone will then validate it. So the Nova database will get an entry ID for the requested VM. And the Nova API actually makes the RPC call to the scheduler. And it actually publishes a short message to the scheduler queue with the VM info that was requested. So this is how it is done through message queue. The API passes the RPC. So the API makes this RPC call to the scheduler through the message queue. The first from API it goes to the queue, and from there it goes to the scheduler. So the Nova scheduler is actually a daemon which actually determines on which compute host the request that you made should run. And then in turn it actually schedules the provisioning. So what happens next is that the scheduler fetches information about the whole cluster from the database about different filters, and it selects the compute nodes and it updates the database with the ID. And after that, what happens is that the Nova compute, this actually asks the Nova conductor for VM info from the database. So it asks the Nova conductor, the conductor retrieves the data from the database, and for doing that, the Nova compute actually makes an RPC call to the Nova conductor for the VM details to get it from the database. And what it will do is that it will query the Neutron to allocate all the networking information for the VM that you requested. So what the Neutron does is that it provides you with a very flexible API for different service providers or their tenants to manage all the OpenStack network topologies. So it can create networks to associate with VMs, it can set routers for your VM, and after that what happens is that it uses different plugin agents to configure your network for the VM. So this is the plugin agents actually define the network for your VM in your compute node. Okay, so the Nova makes a call to the Neutron API to provision network for the instance, and the Neutron actually configures the IP, your gateway, your DNS name, your L2 connectivity, etc. After that, it is time to define the storage. Okay, so there can be two kinds of storage. Since I told you the first one is Swift, which is the object storage, and the second one is Cinder, which is the pluggable or block storage system. Okay, so in block storage system, the data will persist until it is specifically or explicitly deleted by any user, and it is accessible within the VM as a block storage device, and Cinder is basically used to add additional storage to VM, and all of these components are maintained or managed by the Cinder service. And in Swift also, none of the objects or any of the files that you're storing in Swift will not get deleted unless you explicitly delete them. And it is accessible from anywhere in the VM, and it is basically used to add or store files including different VM images. And all of this Swift proxy and object store, I already showed you the architecture of Swift proxy, how it actually redirects it to different containers or how to store it. The Swift proxy determines it. So all these components are managed by the Swift service. And you can say that Cinder is actually used as a backup service to archive your data. While as Swift, you can actually directly integrate with the compute node. You can directly use it for direct storage of your files as an objects from your VM. So after that, the next thing that you should do is you would ask for volume. Now, it is actually assumed that a volume is already created. What the Nova compute does is that it contacts the Cinder to get the volume data. And you can also do that attaching volumes after your VM is created. And volume means the storage area of your VM. Okay. So the Nova sets up the host mount if it is needed, and it instructs the hypervisor to use volume as a new block device. And after that, we come to Glance. So the Glance provides you with services for discovering, registering, and retrieving virtual machine images, right? And it provides you with images service. So it can use multiple backends for image storage. It can also store the same image in multiple locations, and it supports multiple image formats. So it can retrieve it from Swift. So after that, what will happen is that the compute node will actually request for VM image from Glance. It will request the VM image via image ID. So it will ask you, so every image that is contained in Glance has unique ID. Let's say you requested for Ubuntu 64-bit image. So that will have image ID, and that will actually get passed in the request to Glance. So when the Glance API receives that request, it will have an image ID present in it. So when you ask for an image with an image ID, how it can be found is that it can return an URI or HTTP GET URI. Okay? And after that, the VM will start rendering via the hypervisor, and the Nova will create a command to the hypervisor, and it will delegate the VM rendering to the hypervisor. And after that, your VM will be up and running. So it will again send a message to the Nova conductor to update the database with the VM state, and then you'll finally get your VM launched and it is ready to use. So that is how all the processing takes place. That is how each of the components actually communicate with each other. If I have to summarize this whole entire thing, I will tell you that at first you log into Horizon, the Keystone will validate your credentials, then you ask for VM, so it'll contact the Nova. The Nova will again send to the Keystone to validate the authorization rights of the user. It will send back a token after verifying it. Then Nova will actually retrieve the image from Glance, which can be either in Swift or it can be either in Cinder. So it'll get retrieved from that. Neutron will be responsible to provide with all the networking configurations for the VM. So this is the summary of how the OpenStack architecture and how each of the servers actually interact with each other. So any questions over here? Okay, no questions. Okay, so now we'll take into account a case study and we'll understand how CERN has been using OpenStack. So you all know what CERN is. It is the European Organization for Nuclear Research, and they carry out lots of experiments, mostly about particle physics, and there are a number of scientists from different parts of the world contributing onto those experiments. The headquarters of CERN is located in Geneva in Switzerland. So they're conducting a lot of experiments, and there are a lot of scientists actually working on a lot of different projects. So there is a lot of data, and to manage those data, they have got two data centers. One is in Geneva and the other one is at Budapest. So let us now understand why they actually thought of using OpenStack. I'm very sure that you must have heard about the Large Hadron Collider. So this is a very huge machine. It is so huge that it actually stretches between two countries. Yeah, I'm not joking. So what is it? It is basically a particle accelerator. So they pass like two beams which travels with the speed of light, and they collide together, and there are like some kind of detectors to actually study about that collision. So there are detectors inside those tubes, those large tubes, and they detect the impact of those collisions when those two beams actually collide with very high speed. So this is basically the experiment, and it's mostly particle physics stuff. So I don't know much about particle physics, but it definitely interests me a lot. So when you have a huge machine, you'll have even more huge data to manage. So obviously CERN could not rely on typical hardware servers to manage and store all their data. I mean, they have even two data centers to manage the data, so obviously they cannot rely on just typical hardware, because maybe the fundamental laws of physics have not changed, but the technology has definitely changed. So that's why they wanted a private cloud infrastructure, and private in the sense because these are experiments and these are not released to the public directly. So they have to conduct experiments, verify it, and then actually release the results. So that's why they cannot rely on a public cloud, maybe for security issues or maybe because of the amount of data they are handling. So that's why they needed to set up a private cloud infrastructure. They also needed it for backup, because let's say because of a natural calamity, one of their headquarters actually, God forbid, something happens there and they lose all their data. So that's why they wanted backup also. And the best thing to have a backup is always a cloud infrastructure or for a cloud data storage. So that's the reason that they chose OpenStack to set up their private cloud infrastructure. So let us see how they have done that. So if you see their infrastructure by numbers, right now they are using OpenStack, and they have been actually using OpenStack since OpenStack released their first release, starting from SX, and now they are into Okata as well. So they have got 5,000 compute nodes, out of which 4,800 are KVM and 200 are Hyper-V nodes. And they have almost 16,000 virtual machines running on those nodes. They have 2,400 images, 1,800 volumes in those VMs, and there are more than 2,000 users and 2,300 projects going on in the OpenStack cloud. So they are using Nova to its fullest to actually process all those data. So this is their typical structure, the typical architecture of the Nova service that they are using in OpenStack. If you see here, so there is a top cell controller, and they have actually got solely independent API nodes also that actually connects different components together. So everything passes through the API node, and then the top cell controller, the cells are actually the computers, different computers that run. So there is a controller cell, and the other child cells are all controlled by the cell controllers. So each of the child cells are responsible for a specific task, maybe for a specific project, or maybe they are a component of a specific project. So if you see the architecture over here, this is the simple Nova compute or the Nova service architecture. So there are APIs, there's the Nova scheduler, the Nova conductor, the Nova network, and they use RabbitMQ for message queuing, for passing messages on to the different Nova components. So this is a typical Nova deployment by CERN. I'm not going to explain much about the Nova architecture, how Nova works. So this is just the layout of the Nova deployment at CERN. So I hope you've all understood that. Any questions? Okay, no questions. Very well. Okay, so we'll move on. So now let us take a look at the OpenStack success stories, how people have used OpenStack and how they have benefited from OpenStack. So you have got like 4 companies. So you know that JFE Steel is one of the largest steel companies in the world, and JFE Steel with OpenStack has actually reduced 28% on overall IT costs. And Comcast, it uses OpenStack, and their OpenStack cloud spans 84 data centers and supports different platforms, residential email, product development, and Hadoop big data as well. When you see Walmart, which is one of the largest companies in the world, it relies on OpenStack to manage e-commerce. And in AT&T, it connects more than 14 million wireless customers via virtualized networks and has deployed over 70 OpenStack clouds globally. So these companies have actually earned huge success with OpenStack. So now let me show you how you can actually use the dashboard horizon. So this is the web browser in my VM where I have already an OpenStack setup defined. So I'm going to go to my dashboard. So I already have that link. So this is in the IP 10.0.2.15. So I'm just going to click here. So yeah, this is the dashboard. So this is the first thing that you'll see when you open your dashboard. It will ask for your login username and password. So I'm going to log in as admin. And after you have done providing the password, just click on this button over here. So there you have. So this is what you get after you log in into your dashboard. So we are in the projects tab over here. So if you can see different users. So these are the different users, which are basically just services over here, and every one of them has got a unique user ID. So now let us go to this admin tab over here. You can see an overview. So you can actually see the usage summary by also providing with a specific period of time. So this can be actually your Ceilometer service. If you think of this, you can say that active instances, it'll count the vCPU hours, and in terms of how much memory it has consumed, how much RAM it has consumed. So this data can be actually used for billing purposes. So this is what actually Ceilometer monitors. So if you, let's say that I want it from this date to this. So if you submit, so yeah, there it is. So the project name is actually the username that I have logged into. So I've been using 2 vCPUs. For disk, I've been using 2 gigs. For RAM, 1 gig. The vCPU hours is this much, and there are all of the details. So let's say that I want to launch an instance. So let me go to images, because I have to launch an instance from a particular image, right? So this you can actually consider as the glance service. So this is where your images are, and you are going to launch an instance in the Nova. And if I want to launch a Cirrus instance, I will launch this from the image, and I'll click on this button over here, launch. So you have to fill up all these details, okay? So first thing, you need to provide with an instance name. I'll call it OpenStack VM Cirrus. So you also have to tell how many instances that you want of this kind. So the stars that are mentioned, so it means that this is mandatory. You should provide these details before you want to launch an instance. So let me go to flavor. So flavors are actually the size of your instance. So there are different flavors like M1 tiny, tinier, small. So you can actually create your own flavors too. This one was actually created by me. You can actually define what is the size of the instance that you want. You can define the amount of vCPUs, the RAM it should use, the total disk size, and everything. So let's say that I'm going to launch a very tiny image. Let me select the M1 tiny. So you can also configure the network. So I've already got a network defined, which is the public network. The name of the network is public, and the subnets associated goes by the name public subnet. The state is up and active. So I'll just go ahead and click this button over here. Just launch instance. So it showed a message that one instance is launched. So let me go in this instance tab over here. So this can be considered as the Nova service. So this is your instance that you have created. So let's go ahead and power up this instance over here. So let me click here. So this is my OpenStack VM Zeros. So this has the instance ID is this. The status is active. It is launched in the Nova compute zone. So this is when it created. It has been 4 minutes since it is created. So this is the specifications. The flavor is M1 tiny. The flavor ID is 1. So the RAM that I've assigned is 512 MB. It uses 1 vCPU, and disk size is 1 GB. And this is the public IP address. So you can find all the details of your VM over here. So if you want to access this, go to the console. So there you go. This is the console of your instance. So you can log in onto this instance. So the default username is Ceros, and the password is also given to you. So you can use this instance for whatever purpose that you need. You want to run applications. You want to use it for testing purpose. If you want to test your applications on it, you can do that. So this is how your VM gets provisioned. So now if you go to the networks tab over here, so here you have, these are your networks that are defined, the public and private network. This is for the demo user or the demo project. So now, okay, now if you go to project, if you want to see the network topology of your VM or instances or the infrastructure you have, how your network is connected to the VMs and everything, you can just go and click over here. So there you have, so this is your public network, and you've got 3 instances connected to it. If you want to see the graph, this is it. So this is a better way of seeing it. This one looks better, doesn't it? So if you want to see the labels. So this is the public network, this is the VM we just created, and these were the two VMs, the pre-existing VMs that we already had in our OpenStack infrastructure. So this is how you can use OpenStack, and this is how you can actually manage everything using the dashboard, OpenStack Horizon. You can access everything. This is the object store. You can go ahead and explore everything over here. So this is how you do it. Any kind of questions till here? Does anybody have any questions? Okay, so no questions. So to summarize what we have learned today, we have learned the different virtualization concepts. We have learned what is OpenStack and why do we actually need to use OpenStack, the OpenStack architecture, the different components, and we have taken a look at the different success stories by various companies who have used OpenStack. So any doubts still here? You can still ask me if you have any doubts in any of these sections. No doubts. Great. Okay. Thank you everyone for joining today's session. If you want to learn more about OpenStack, you can actually visit Edureka's website and you can explore what more you can learn about OpenStack in Edureka's course curriculum. So you can go over there, check it out. And if you have any doubts, any queries, or if you want to give any feedback to me, kindly post it in the comment section below. Thank you everyone for watching this, and I'll see you next time. Till then, happy learning.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!